Students, in this video I am going to explain SP3d and SP3d2 hybridizations with examples. For SP3d hybridization, best example is PCl5, phosphorus pentachloride. In PCl5, center atom is phosphorus. Phosphorus atomic number is 15. Configuration is 1s2, 2s2, 2p6, 3s2, 3p3. 1s means first level, 2s, 2p means second level, 3s, 3p, and here 3d empty orbital is also there. So in its outermost level, S contains 2 electrons and P contains 3 electrons. So phosphorus has 3 unpaired electrons, but in PCl5 phosphorus is bonded with 5 chlorine atoms. So it should have 5 unpaired electrons. So by jumping s electron into d orbital, we can get 5 unpaired electrons. So on excitation, phosphorus on excitation, from s level to d level, here empty d orbital is there. From here to here, s electron jumps and there are 3 p unpaired electrons. So here the hybridization is SP3d. So hybridization is SP3d. Phosphorus undergoes SP3 hybridization. Here 1 plus 3 plus 1, total 5. So phosphorus undergoes SP3 hybridization, SP3d hybridization to produce 5 SP3d hybrid orbitals. And chlorine atomic number is 17, 1s2, 2s2, 2p6, 3s2, 3p5. So in its outermost level, it contains 1 pz electron, 1, 2, 3, 4, 5. So here pz is ready for bond formation. So after sp3d hybridization in phosphorus produces 5 sp3d hybrid orbitals. 1, 2, 3. Among the 5, I am arranging 3 hybrid orbitals in equatorial position and 2 hybrid orbitals are above the plane and below the plane. So this is equatorial position, this is above the plane and this is below the plane. So in phosphorus, each orbital contains 1 electron. So among all these, I am arranging 1 electron each. So with these 5 sp3d hybrid orbitals, pz orbital of chlorine, this is pz orbital of chlorine combines. So chlorine combines with 1 unpaired electron, and here also chlorine combines with 1 electron. Here also pz orbital, another pz orbital, here also another pz orbital. All these pz orbitals are pure orbitals. So the shape of the molecule is like this. This is trigonal, and here from here to here one pyramid will obtain. Bottom side also. So this is trigonal bipyramidal. This is triangle. Above the triangle one pyramid is there, and below the triangle one pyramid is there. So this is trigonal bipyramidal. Trigonal bipyramidal shape. And the bond angles are in triangle there is 120. So bond angles are 120 degrees. And second one, above the plane, below the plane. Above the plane orbital forms 90 degrees bond angle with equatorial position. This orbital forms 90 degrees bond angle. So 120, 90, and from above the plane to below the plane we have 180 degrees. So in PCl5 there are 120, 90 and 180 degrees. So all these are chlorides. And what are the types of bonds formed in PCl5? So these orbitals are SP3d. So there are 5 SP3d hybrid orbitals, and this one is pure p orbital. So in PCl5 we have SP3d P, SP3d P, SP3d P, like that we have 1, 2, 3, 4, 5. So 5 SP3d sigma bonds. 5 SP3d sigma bonds are there in PCl5 molecule. And the bond lengths are different in PCl5. In PCl5, the bond lengths in equatorial position, phosphorus chlorine bond lengths in equatorial position, that means this one, and this one. This is equatorial. In equatorial, there are 3 PCl bonds. This one, and this one. In equatorial position, there are 3 PCl bonds. The PCl bonds present in axial. Axial means these two. PCl. So these two bond lengths are more than that of these 3 bond lengths. So the bond lengths present in axial position bond lengths are greater than that of bond lengths of PCl in equatorial. So we have to remember this one. The bond lengths in axial position, PCl bond lengths in axial position are greater than that of PCl bond lengths in equatorial position. In the second example, SP3d2 hybridization. For SP3d2 hybridization, example is SF6. SF6. SP3d2 hybridization, SF6 molecule. In SF6, central atom is sulfur. Sulfur atomic number is 16, 1s2, 2s2, 2p6, 3s2, 3p4. So this is first level, this is second level, this is third level. In third level, it contains 2 electrons in S and 4 electrons in P. Here empty 3d orbital is also there. So sulfur is attached with 6 fluorine atoms. So sulfur should have 6 unpaired electrons, but it contains only 2 unpaired electrons. First we have to jump this electron from px 3px to 3d, and second time we have to jump this electron from d. So on first excitation, 3s electrons will be here only, and one electron from here to d orbital. So one electron jumps from px to d orbital. On second excitation, from s to d, from here to d here. So the hybridization will be SP3d2. So this is SP3d2 hybridization. In SP3d2 hybridization, we will get 1 plus 3 plus 2, that means 6 hybrid orbitals. In fluorine atomic number is 9, configuration is 1s2 2s2 2p5, 1s2 2s2 2p5. So it contains 1 2 3 4 5 pz orbital. So pz orbital of fluorine is ready to bond with sp3d hybridized orbitals of sulfur. So in sulfur there is sp3d2 hybridization. So in sulfur there is sp3d2 hybridization. Sulfur undergoes sp3d2 hybridization to produce 6 sp3d hybrid orbitals. These are the 6. Out of 6 I represented here 4, and the remaining 2, one is above the plane and another one is below the plane. Each orbital contains one electron. So 1 1 1 1 1 1, total 6 unpaired electrons. With these 6 unpaired electrons, the pz orbital of fluorine combines. Pz orbital of fluorine. So here this is pz orbital of fluorine, 1 and 2, this is 3, this is 4, and here 5, and here 6. So the shape of the molecule will be, this is square, from here to here a pyramid will be formed. Square, one pyramid above the plane and second pyramid. This is second pyramid. So above the plane one pyramid, below the plane one pyramid. So it is square bipyramidal, or we can call it as octahedral. So this is square bipyramidal or octahedral. You can call it as octahedral. And the bond angles are, in square we have 90 degrees. So bond angles are 90 degrees. And from above the plane to below the plane, above the plane to below the plane, it is 180 degrees. So in SF6 or in SP3D2 hybridization, we have only two bond angles, 90 degrees and 180 degrees, whereas in SP3D we have 120, 90 and 180. So here the types of bond formed are, this is sp3d2 hybrid orbital, this is pz, sp3d2p, sp3d2p. So there are 6 sp3d2 bonds, sigma bonds, 6 sp3d2 sigma bonds. Here also the bond lengths of sulfur and fluorine in axial position are greater than that of bond length of sulfur and fluorine in equatorial position. The bond lengths of sulfur and fluorine in axial position are greater than that of the bond lengths of sulfur and fluorine in equatorial position. So these are the two examples of sp3 dehybridization and sp3d2 hybridization.